Hello, ladies and gentlemen. I hope everyone is doing well today. Today we are beginning the next unit, and we're going to start with the Chemquest covering Bohr's atomic model. So you should already have this first page completed from our class discussion. If not, please ask me for the notes to have a short discussion with you the next time you see me. So this means that we can begin on the top of the second page. So we all know that we compare Bohr's model to the solar system model. We compare it. We call the electrons. We call the path that they travel in orbits, just like the planets orbit in circular paths of the sun. The electrons do the same thing for the nucleus. They take circular paths. Unfortunately, we now know that it is a little bit more complicated than that. There's a little bit more going on inside of those orbits. So what we're going to start doing is we're going to start calling those orbits energy levels. So you can see that in the diagram over here. This is a Bohr diagram. So in this Bohr diagram, now the orbits, the circular paths that the electrons were taking, those are now called energy levels. Remember, we see the electrons are the black dots. So we see that the energy levels orbit the circular path to go around the nucleus, and they contain the electrons. Inside that nucleus, remember, we have our protons and our neutrons. Our protons are the white dots, our neutrons are the gray dots. One other thing worth noting is that we give the energy levels names. We name them with numbers. The orbit, or the energy level that's closest to the nucleus, that's always labeled the first energy level, or 1. And then we increase by increments of 1 from there. So that's why the second closest is the second. If there was another energy level, it would be called the third, and then the fourth, and then the fifth, and so on. It is worth noting that the different energy levels can hold different numbers of electrons. In the next Chemquest, we'll figure out how many each could hold. But for this one, all we need to know is that the first energy level contains 2 electrons, the second energy level contains 8 electrons, and the third energy level can hold at least 8 electrons. It can hold more than that, but like I said, the next Chemquest, we'll worry about calculating that later. So now we can move on to question 5. Question 5, we're going to look at the Bohr diagram that's up top, and we need to identify the atom. So remember, to identify atoms, we need to remember that the number of protons equals the atomic number. So we can look at this diagram. Protons are the white ones, so we can count them up. 1, 2, 3. So we know that equals 3. So then next we can use our trusty old periodic tables, and we can use it which element has an atomic number of 3, and that is our answer. So next question 6. Next question 6, we are going to start drawing some Bohr diagrams. It's worth noting that we're drawing atoms. So when we're drawing atoms, what we need to remember is that the atomic number equals the number of protons, and then because we're dealing with atoms, they have a neutral charge, which means the protons also equal the electrons. So that's how we can figure out the protons and the electrons for these Bohr diagrams. Next, we would have to figure out the neutrons. To figure out the neutrons, we can use the formula mass number equals protons plus neutrons. Remember, guys, your mass number, on your periodic table, you can round it to the nearest whole number. And then if we rearrange this formula a little bit, subtract protons from both sides, that equals the neutrons. So what we see here is neutrons equals the mass number minus the protons. So watch. I'll use this information right here. The new information I gave you about how many electrons each energy level holds right up here to help you draw sulfur. Then you can model the same steps, drawing for carbon, sodium, and phosphorus. So we need to first find sulfur on our periodic table. Sulfur is over here. So we see that sulfur has an atomic number of 16. So that tells us that it has 16 protons and 16 electrons. So I'm just going to list that. 16 protons, 16 electrons. Next, we need to figure out the neutrons. So we can use the neutrons, which is equal to the mass number minus the protons. Remember, we can round the mass number to the nearest whole number. So we look right here. Sulfur has a mass number of 32.066, so we can round that to 32. So we can say neutrons equals 32. minus 16, because we already figured out it has 16 protons. So then we find that it has, not 13, I can't do mental math, we find that it has 16 neutrons as well. So now we can take that information and we can draw a Bohr diagram. So remember, in our Bohr diagram, in the nucleus, we have our protons and our neutrons. So you guys do not have to draw little dots for them. Instead, we're just going to write them. So we put in our nucleus 16 protons, 16 neutrons. We know that's our nucleus. Now we can start drawing energy levels around it. We need to fill in a total of 16 electrons. So, oh, my cat. She just came to say hi. Making a mess. Well, let me get her out of the way quick. Okay. So, back on the problem. So we already filled in our nucleus, our 16 protons and our 16 neutrons. So now we can start filling in our energy levels to fill in our electrons. So remember, the first energy level can hold 2 electrons. So we would draw an energy level, and we put 2 electrons in it. We haven't quite filled in 16 yet. We've filled in 2. So we can cross off our 16. So we had 16. And now we have 14 left to fill in. So now we can draw another energy level. Remember, guys, the second energy level can hold 8 electrons. We're going to postpone. So now we can draw 8 electrons in our second energy level. 1, 2, 3, 4, 5, 6, 7, 8. We haven't quite filled them all in yet. We have 6 left. So now we can fill in the third energy level. We only have 6 left, so we only put 6 in. 1, 2, 3, 4, 5, 6. You have now drawn the Bohr diagram for sulfur. So now model the same steps for carbon, sodium, and phosphorus. Remember, use this information, find the atomic number to find the protons and the electrons. Then use the mass number and the number of protons, use the mass number and the number of protons to solve for the number of neutrons. Then fill in the dots, the number of electrons that can be present in each energy level. Remember, if you have any questions, write down your question, write down where you get stuck. The important thing is that you attempt them. So then next we have some information on light. Let me zoom out a little bit. So when I went to highlight important information in this paragraph, it was really difficult because it was all very important. So right now we're going to read through it quick, and then I'll show you guys, we'll use the questions and the next models on the next page to work through the information. So when an electron absorbs light energy, it goes to a higher energy level, and then it's said to be excited. So just like you guys, when you guys get excited, when you have energy, you can't hold on to that energy forever. Eventually you need to lose that energy. Eventually you need to release it and relax. Same thing with electrons. Except when electrons lose energy, they release different colored light energy for us to see. The color of light depends on how much energy is released. Different atoms will release different amount of energy, so therefore you'll have different colors. So therefore, different colors. Once an electron releases that energy, it goes into the ground state. So we can think of the ground state as the normal state, and I will show you guys what I mean by all of these different terms right now. So on the top of the next page, we have 2 atoms drawn for us. They are the same atoms on the same lithium atom that we were looking at in the previous one, so we know that it has 3 protons, 2 neutrons, and 3 electrons. So this first one on the left, this is the ground state or the normal state. So the reason why I call it the normal state is because this is just your standard Bohr diagram. So if you were to just draw a regular old Bohr diagram, the ground state is just what it normally looks like. So all of the models, all of the Bohr diagrams you drew over here, these are all in the ground state. So this one is in the excited state. So let's look and see how it's different. So we can look at the first energy level. We notice that the first energy level, instead of having 2 electrons in it, it only has 1. So what happened is this electron right here, that electron gained energy and jumped up an energy level. So what you see here is that the second energy level has electrons in it, has electrons occupying it before the first energy level is full. That's a big no-no. Remember, guys, you're supposed to fill in the first energy level before you start filling in the second. So something special happened. It gained energy to jump up. So what's important, though, what's worth noting, so if we were to draw a second model of this, so when it's worth noting, guys, so when this electron loses energy and goes back down from the second energy level to the first energy level, so this is when light is released. Light is released when the excited electron relaxes and goes back to the first energy level. So that's really important to know. So this is when the light is released. It's not released when you don't see the light when the electron is excited. You see the light when the electron gets relaxed, when it goes back from the excited state to the ground state. That is when you see the light. So now we can use question 7. So using what we just said a little bit, how can we tell if an atom is in the ground state or an excited state? What's different about the picture on the right than the picture on the left? So what we saw here, guys, is remember that you have electrons in the second energy level before the first energy level is full. So if we want to say that in like more general terms and more broad terms, what we're looking for, so it's excited when there is an electron in an outer energy level before an inner energy level is full. And then remember, guys, oh, sorry, now you can read it, it's not tilted. So remember, it's excited when there is an electron in an outer energy level before an inner energy level is full. And then remember, guys, it is in the ground state when it's just your standard Bohr diagram. So ground state is your standard Bohr diagram. So when you're answering number 8, you can use what we just wrote to help you answer these questions. So remember, what you're going to do is you're going to look at the outer energy level. Do you have electrons in the outer energy level? Are all of the inner energy levels full? That's what you need to ask yourself. Remember, in the first energy level, you can have 2 electrons. Remember, in the second energy level, you can have 8 electrons. And in the third, you can have more than 8. And it doesn't matter at this point knowing exactly how many are in the third. Remember, we're going to calculate that in the next one. And it doesn't matter because we do not go past the third energy level. So when you're looking at these pictures, make sure. Remember, it's the ground state if the inner energy levels are full before the outer energy levels are. It's excited if the inner energy level is not full and there's electrons in the outer one. So try your best working on number 8. Do you think they are excited or not excited or in the ground state. Then lastly, we have questions 9, 10, and 11. Questions 9, 10, and 11, we've already discussed all of the information, and it can all be found right here on this information in this paragraph and what we wrote in the margin. So reread this paragraph and use that information to help you 9, 10, and 11. Remember, guys, if you have any questions, all I care about is that you attempt them and show me that you're thinking. So write down where you get stuck, write down what you need help with, and you'll still get credit. Like always, we'll end with a joke. So why did the coffee file a police report? Because it got mugged. I hope everyone has a wonderful day. I'll see you guys next class. Bye.